Hello and welcome to the Maths Jedi once again. This is another video in my A-level series. This one today is looking at algebraic fractions. This fits well with the second year of the A-level course. So if you worked your way through the AS level course already, this will be probably one of the first topics that you'll do in the upper sixth. So I just would like to go through some of the basics first of all, some of the reminders of stuff that you probably did at GCSE, reminding you of some of the things that you just need to look for when you're doing algebraic fractions, particularly with simplification and factorisation. When you're doing algebraic fractions, the important thing is to recognise that you can never divide by zero. So it's important to understand that the values of x have to be defined appropriately. So you'll always see in exam questions a little bit of a disclaimer to say x can't be certain values. So for example, in this particular fraction, x can't be minus 2, because if it was, you'd be dividing by 0, and that's not a defined value. So just be aware that when you're seeing exam questions, you may well see that in the margin or at the side, just to remind you that you can't divide by 0. When you did GCSE, you were used to cancelling fractions at a basic level, and so obviously you're looking for factors on top and bottom in this example. And of course, when you're doing factors of numbers, you're looking at very simple things. But of course, you can do the same thing with algebra also. And at GCSE, you'd have been used to seeing factors of algebra in the same way. So for example, when you look at what this top and bottom has in common, you can see they also have a factor of 2 in common, and they have a factor of a in common. So if you divide by a, in fact it's a squared, and 2 here on both top and bottom, you can cancel things through. In a similar way, if you're trying to factorise as much as possible, you're always trying to search for things that you can do. So for example, difference of 2 squares here is worth noting, and you can also see that it's got p in common, and at the top also p in common, and everything is also a multiple of 3. So you could probably divide through by 3p in this example. A nice simplified algebraic fraction at the end is always a good example of where you should be. When it gets more complex, you're looking to factorise in a different way. So obviously you'd be looking to take out linear factors, and that's what this particular question is doing. Similarly, in this one, you're looking for linear factors that they have in common. Notice the difference 2 squares underneath. And so you're looking to cancel linear factors here. If you factorise the top, factorise the bottom, and then cancel by linear factors, you can get yourself a very nice simplified form at the end. This is all stuff you should have done at GCSE, so it should not be new, but this is something that perhaps you haven't seen much reference to at GCSE. It's called an additive inverse. So you probably have seen versions of it, but never named as such. So just be aware that you can see if you've got two numbers that are differences like this, so a minus b, you can represent that as an additive inverse. You can take out the take out the minus 1 and divide everything by minus 1. Similarly, you can do it here. And where does that help you? It helps you in examples such as this. You can see hopefully the top is an additive inverse of the bottom. So you can see them rearranging it in that form. And then of course you're just left with minus 1 in this particular example. So additive inverses are important if you're trying to see things that they've got in common. Make sure you're understanding that you can divide through by a factor of minus 1 to make things easier when you've got subtract problems. Here again, another example of additive inverses. So you can see them factorising on the top and on the bottom, and you can see that these two linear factors are additive inverses of each other, so they'll use an additive inverse to cancel those things through. Again, a nice simplified form of the algebraic fraction at the end. They call these complex fractions. I would say they're just very, very complicated fractions. But be aware again, you can just look at always a numerator in isolation if you want to, and start multiplying things through to make this a bit simpler. So if you look at just the numerator, you can divide everything, you can multiply everything by x, just to make things a bit easier for yourself, and that will help you a lot. So you can see them working that through here, and you can see they've taken that x that they multiplied through and they've added that to the bottom, so x cubed here. So it's 3x plus 1 over x. They've multiplied everything by x on the top, and they've multiplied everything by x on the bottom. As long as you do the same thing to the top and bottom, the fraction is preserved. When you get more complicated examples, it's just worth noting that you can start to look at things that you can simplify a bit easier. So here on the top you can see they've got an a as a denominator, and on the bottom they've got a 3 as a denominator. So there's things that they can do by multiplying by 3a. So they've multiplied everything by 3a, all of the things on the top by 3a, and all of the things on the bottom on 3a, and you get to a fairly easy form that you can simplify quite quickly. These are just little tricks for you to bear in mind, and things that you perhaps have met before, but just worth bearing in mind for when you look at complex examples. This one's a bit more difficult, but again, similar. You can see that these have got factors in common, so x squared is the multiple of both of those, and 3x is obviously the denominator here. So if you're looking at multiplying things, it would make sense to look at the lowest common multiple of all of those things. So x, x squared, and 3x. So that's got to be 3x squared. So in this example, you're looking for a lowest common multiple of x, x squared, and 3x. It's a bit like when you added fractions at GCSE and lower down, that you're looking for a lowest common denominator. Similar way, that's kind of what you're doing here. By multiplying 3 by 3x squared, you're then creating a nice algebraic fraction that you can simplify very quickly. When adding and subtracting fractions, you're always used to finding the lowest common denominator, as I just mentioned. Again, same thing is true in algebraic fractions also. So as you're working your way through number examples, it's just a similar way of working, but with algebra instead. So you're looking for a lowest common denominator at all times. In this case, the lowest common denominator in this case is x squared. So you're going to see them multiplying everything on the right hand side by x. So that's what they're doing here. And then they're getting a nice simplified form. Here again, looking for a lowest common denominator would be 3xy. So you can see them working their way through to get that particular algebraic fraction solved. Again, these are things that you should have done at GCSE, but just a reminder of some of the more tricky examples, just to keep your mind on those things. Look at this one real quick. Factorising, of course, where possible, is always a useful thing to do before you find your factor, because actually if you factorise first, you can see there are things that you can cancel through. So by looking at these things, you can see a lowest common denominator quite quickly. Again, here you've got a real number take away a fraction, so you can look for a common denominator again. If you multiply everything here on x squared plus 5 on top and bottom, you can see them creating a algebraic fraction that you can then solve. You can see them multiplying it out, collecting like terms accordingly, and subtracting through. This is where you'll more be at A level, is on multiplying and dividing fractions, and just like in GCSE when you were doing normal algebraic fractions, the same thing is preserved here. This is working through an example with numbers, but the same thing is true of algebraic fractions. You're looking to cross cancel if you can. So here they're cross cancelling by 7 and 3. And in algebraic fractions, you're looking to do the same thing. So factorisation is the key, and learning to factorise things quickly. So on this left-hand fraction, you can see them writing out as linear factors. So factorising the top and factorising the bottom. Once they've got a factorised form, they can start to cancel out linear parts, leaving you with a nice algebraic fraction at the end. Similar example, notice the difference of 2 squares on the top. So x plus 2x minus 2, 3x here, x plus 2 and 2x minus 4. They're dividing through on the bottom by 2 here, and they can see cross cancellation can happen quite quickly. When you're dividing, a reminder that when you're dividing anything that's a fraction, you just multiply by the same fraction upside down. So what they're going to do here is they're going to change it to a multiply sum, and they're going to flip the second fraction. So very similar to what you were doing with normal numbers, but just again looking for cross cancellation where you can. Notice here we've got a more complex quadratic, so they're going to flip this fraction upside down and then factorise on the top. Again, looking for cross-linear factors that they can cancel, and there's numbers here that cancel also. I've whizzed through that a little bit, but it's important now to look at some questions. So we're going to go into the book on page 6. This is the upper 6th book, the year 2 book. So again, just be aware this is a new book now, so year 2 book for pure maths. So we're going to look at exercise 1b. We're going to focus in on some of the exam questions at the end, and I'll do questions 4 to start with and some of the latter ones as well. So it give you some good understanding, and then you can probably practice the rest in your own time. I'm just going to move my pen over a little bit so I've got more room to scribble. And we're going to look at number 4. So I'm going to take my pen. We're going to look at number 4. So notice first of all how this is quite a complex problem. Lots and lots of algebra here. So 2x squared minus 11x minus 40 over x squared minus 4x minus 32 times x squared plus 8x plus 16 over 6x squared minus 3x minus 45, and then divide by 8x squared plus 20x minus 48 over 10x squared minus 45x plus 45. And we've got to simplify that into a very easy form, a and b, where a and b are constants. So all the algebra is going to go. So we need to be very careful how we do this. Just take our time with it as we go. So the first thing I'm going to do is just get my pen and just make sure that I've got some manipulation happening. So let's get my colour happening here. And we're going to look at the first fraction. So the first fraction is 2x squared minus 11x minus 40, and then over x squared minus 4x minus 32. So I'm going to simplify this fraction first. So again, if I look at the bottom first of all, we're going to factorise what's on the bottom. So if you look at 32, we're looking for numbers of factors of 32 that add to make minus 4. So we can get those quite quickly. Again, if you're not particularly great at factorising, I would suggest you definitely do need some practice. Make sure you're giving yourself a good understanding of these things, because obviously if you can factorise well, you can do these questions quite quickly. So the bottom factorises as x minus 8x plus 4. Let's do the top now. Again, a reminder of how you factorise quadratics with coefficients of x squared. You can either do it by inspection, just by looking at it, or you can do some manipulation. So it depends on how you were taught at GCSE or which method you best prefer. I can do it either way, but I'll show you both just so you're sure. So actually, just by inspection, I can see that 2 is prime. So I know that this particular bracket is going to start with a 2x and an x. And then looking for factors of 40, a manipulation of those factors to give you 11. So I'm thinking possibly through a range of different numbers. So I'm going to be thinking of 5 and 8 here. And I can see that 2 lots of 8, 16, and then obviously take away the 5. So we've got a manipulation there. So I've got a plus 5 and a minus 8. So 2x minus 8, so 2 times minus 8 is minus 16, plus the 5, that makes minus 11. So by inspection, you can do that. If you're not clear about how I did that, the other way of doing it is to do 2 times minus 40, which is minus 80, and then looking for factors of minus 80. So in this case, it would be, I suppose you could have minus 20 and 4. You could have minus 4 and 20. Minus 16 and 5, minus 5 and 16, and you can see that this is the combination that you need, the minus 16 and the 5, because minus 16 add 5 is minus 11. When you're factorising then, you start with the same thing, so 2x squared, I'm going to write minus 16x here, plus 5x, so splitting that across, and then minus 40, and then you look to factorise the first pair, and factorise the second pair. Again, looking for a pair of brackets that are the same, and you can see quite quickly 2x plus 5, x minus 8, the same pair. Okay. So here in this particular fraction, you can see already we've got some cross cancellation, so I'm going to cancel that through. And so this first fraction, it just simplifies to 2x plus 5 over x plus 4. So 2x plus 5 over x plus 4. I'll delete the rest for now. We'll look at this second fraction. So the second fraction is this one, x squared plus 8x plus 16 divided by 6x squared minus 3x minus 45. And again, I'm going to factorise the top. Top's quite easy to factorise because it's just x plus 4 squared, so it's x plus 4 times x plus 4. At the bottom you can see there's a factor of 3 here, so I'm going to start by taking out a factor of 3 just to make the factorisation a little bit easier for myself. So that leaves me with 2x squared minus x minus 15. And then we're looking for factorisations of 2x squared minus x minus 15. So again, you could do that in a variety of ways, by inspection or by second method. So I'll do that again the second way. So 2 times minus 15 is minus 30. And I'm looking for factors of minus 30. So minus 6 and 5, I think will do it. So minus 6 and 5, that makes minus 1. So then you're left with, in terms of factorisation, 2x squared minus 6x plus 5x minus 15. And then factorising the first pair and the second pair, you can take out 2x as common. That's 2x plus 5, x minus 3 on the bottom. So 2x plus 5, x minus 3. So the second fraction will be x plus 4, and then 3, 2x plus 5, and x minus 3. No cross cancellation in that one just yet, but we can do some things with that in a minute. Forgot to put my line in. And then the third one. Now this is the division, so we're going to flip this one upside down. Again, there's some numbers that these have got in common, so to make things easier for myself, I'm just going to divide through by those numbers, make it slightly easier. So on the top, there's all multiples of 5 here. So I'm going to multiply it through by 5. So I've got 2x squared minus 9x plus 9. On the bottom, I'm going to divide by 4. So I get 2x squared plus 5x minus 12. And again, now I'm looking for factorisation of this and factorisation of this. So we'll do the top one first. So 2 times 9 is 18. I'm looking for factors of 18. So 9 and 2, 18 and 1, 6 and 3. And it's minus 6 and minus 3 is the pair that we need. So again, in factorisation of that, we have 2x squared minus 6x minus 3x plus 9. We're going to factorise the first pair, factorise the second pair, and we have 2x minus 3 brackets x minus 3. So let's just correct that up here. So 2x minus 3, x minus 3. And on the bottom, we've got 2 times minus 12 is minus 24. And we're going to look for multiples of minus 24, factors of 24, sorry. So that's minus 6 and 4, minus 12 and 2, minus 8 and 3, and 8 and minus 3. And it's this pair we need, because that makes positive 5. So again, in factorising the bottom, we have 2x squared plus 8x minus 3x minus 12. We factorise the first pair, take out 2x as common, factorise the second pair, take out 3x as common, and we have 2x minus 3, x plus 4. Okay, so I've factorised all the sums there. What we're now going to do is do some simplification, but we have to just scribble all this out so we can make sense of it all. Again, all of this so far has just been GCSE factorisation. So if you're really good at factorisation, this should be relatively simple to get to here. This stuff isn't particularly tricky if you're good at factorisation, but that's a big if. So you need lots and lots of practice, and you can download lots and lots of sheets off the internet. And as I said, later on you can try all of exercise 1B to make sure you can practice all of those earlier questions to make sure you've got it under your belt. In terms of some cross cancellation, we can do some things here. So this last sum, you can see straight away I've got 2x minus 3 on top and bottom. And then what I will have is this multiplied by this multiplied by this. So we can do one thing at a time and we can work our way through. So I'm going to write it all out as one sum. So this is the first fraction. The second fraction was this. And the third fraction was this one. So that's this bit and this bit, and then 4 brackets x plus 4. Squeeze it in there. Right, so then we're looking for things that we can cross cancel. So you can see straight away, I've got an x plus 4 here and an x plus 4 there. I've got an x plus 4 here and an x plus 4 there. I've got an x minus 3 here and an x minus 3 there. And I've got a 2x plus 5 and a 2x plus 5 there. This becomes 1. This is going to be a third. And this is 5 over 4. That creates the fraction 5 over 12. So in terms of the two numbers here, a and b, a is 5 and b is 12. That was question 4. I'm going to trash my annotations now, and I'm going to work my way through to question 5. So bear with me a minute while I sort that out, and I'll be back with you in just 1 second. Okay, so welcome back. Here's question 5 we're going to look at real quick. Again, an exam type question we can look at the focus on. Starts out with an algebraic fraction, then leads on to some logarithms. So we can look at both parts and get this nailed. And then, as I said, you can work your way through the rest of exercise 1B in your own time. So we're going to look at the first one first of all. So it's saying simplify fully. Again, starts off with a very simplistic take on these algebraic fractions. So again, we're going to start by focusing on this first fraction, just factorising on top and bottom. So factorising on the top and bottom. And I can see quite quickly that you've got x plus 6, x minus 4 on the top. And again, you've got a factorisable quadratic on the bottom. So if you take out what's common, we've got 2x, x plus 5. And in the second fraction, real quick, we're going to multiply out. So x squared minus 3x, we're going to take out what's common on the top. So x brackets x minus 3. And at the bottom, we have a factorisable quadratic. 6 and 3 are the factors. Need to get them around the right way. So plus 6 minus 3. That will work. So then we're looking at how we can cancel on top and bottom. So you can see x minus 3 is going to cancel on top and bottom. The x plus 6 cross cancels. And that leaves me with x cancelling on top and bottom. So I'm left with, let's change my pen colour. I'm left with x minus 4 on the top. And then 2 lots of x plus 5 on the bottom. In terms of part B, it says, given that all these log expressions, find x in terms of e. So this is quite an interesting question because it's sort of translating through to the chapters we've been looking at with exponentials and logarithms from the first year, from the AS stuff. So what does it actually asking you to do? And it's just using the rules of logs here. So you can see that they've got 2 logs being multiplied up. And you've got another complicated set of rules here. But actually, these two things are very, very similar. They're just using rules of logs to translate that information. So first of all, if I get everything that's got a log expression all on the same side, We're going to put all those things with logs on one side and leave the numbers on the other. So all this stuff's going to move. I need to move my pen. This might go over the page a little bit. Okay, and then again, because we've got two logarithms being subtracted, I can write them as a fraction. And of course, I forgot the number part, but the 2 is left over here. And the 2 is left over there. So you can see in this expression here, we have exactly the same thing as this. We know already this makes this. So we're going to have log of x minus 4 over 2x plus 5. That's equal to 2. Just going to remove this a little bit. Then we're going to anti-log everything. So we're just going to anti-log everything. So in other words, we're just going to remove the log. So again, just a reminder about what it means by anti-log. Just put that in there. With logs, of course, any logs, we've got a base. This base is e. So that's the base. This will be the result, and this is the power. So the base is e, this is the outcome, and this is the power. So I can rewrite this. I can anti-log everything. E to the 2, the base to the 2, that's the power, is this outcome, x minus 4 over 2 brackets x plus 5. Now we've got some algebraic manipulation to do. So I'm going to multiply everything by 2, first of all. Multiply everything by x plus 5. Multiply out my brackets. Take all the x expressions to the same side. And the numbers to the other side. Divide through by x. And then divide by this bracket. I don't like the top bit horrible, so I'm going to use some additive inverses to help me out. Just double check the answers. And there it is there. So this is a variation on it. So you can see they've just flipped the bottom there. They've taken the minus on the bottom to make it 1 minus 2e squared. Both these things are equivalent. I'm happy that these are the same. Okay, that brings to an end the questions that I would like to do. I think these are the most interesting questions, 4 and 5, probably the hardest ones as well. That gives you an opportunity now to go through and try number 6 and try all the earlier ones as well in exercise 1b. So I definitely would encourage you to do that in your own time. That's all for today's work. Hopefully we'll catch you next time on the Maths Jedi channel. If you're new to the channel, I really would appreciate it if you could leave a like. That would help out the channel a ton, just help support us to keep going, and also if you could subscribe, that would be very, very helpful indeed. Thank you very much for watching for today, and hopefully see you next time. Bye bye.